Hi, everybody. In our last screencast, the fourth segment in the Rational Functions screencast series, we're going to be putting all of this together. So you're going to be finding the domain, the asymptotes, the x-intercept, the y-intercept of a rational function. We're also going to be graphing the rational function. Okay, so I'm going to go through three nice examples for you. So here's our first example. F of x is equal to 3x minus 4 over x plus 1. Always, if you're going to graph this function, you should be thinking, what's the domain? Well, the top and the bottom are both factored, so the domain of the function is all reals except -1. So then what's the vertical asymptote? It's x equals -1. And then what's the horizontal asymptote? Well, since the degree on the top is the same as the degree on the bottom, the horizontal asymptote is y equals 3. And now we have to find the x-intercept. To find the x-intercept, you're going to set the numerator equal to 0. So what makes the numerator equal 0? When does 3x minus 4 equal 0? And that happens when x is equal to 4/3. So the x-intercept is 4/3. And lastly, we have the y-intercept. So the y-intercept is what you get when you plug 0 in for x. So if I plug 0 here and 0 here, I'll end up with -4 over 1. And so the y-intercept is -4. Okay, now, how would I graph this? Well, the first thing I'm going to do is I'm going to graph my asymptotes. So I graphed here. Here's our x and y axis. And the blue dotted line is the horizontal asymptote, y equals -4. I'm sorry, y equals 3. Sorry. So the horizontal asymptote is y equals 3. The vertical asymptote is x equals -1, and that's highlighted in red. Y equals -4 is on the next picture because that's our y-intercept, and x equals 4/3 is our x-intercept. So based on what I know about these rational functions, I know that the bottom half of my function is going to have this shape. Remember, like most of these horizontal functions have that C-shaped or L-shaped kind of. And I know the other part's going to be up here. Absolutely verify that with your calculator. Okay, let's move on to the next example. So f of x is equal to x squared plus 2x minus 3 over x squared plus 4x plus 3. The first thing we're going to do is factor the top and factor the bottom. And then we see that there's a common factor here. So we're going to factor out that common factor. The common factor is x plus 3. So what we have left is x minus 1 over x plus 1. And just like before, we're going to determine the domain. Now the domain, remember, comes from here. So the domain is all reals except -3 and -1. And that comes from what makes the denominator 0. Not from when it's factored, but or not from when you cancel out the common factors, but here in this step. And then the vertical asymptote, though, remember, is just x equals -1. That does come from the simplified function. I hope this is all making sense. Okay, so what happens when we have a disconnect here? So when there's a disconnect between what we have in the domain and what we have as the vertical asymptote, there has to be a hole. Okay, so the hole is going to be at -3 because it's not allowed to be in the domain, yet it disappears whenever we factor out the common factor. It is the common factor. So we have a hole at -3, 2. How did I figure out the 2 part? Well, I plug -3 in. -3 minus 1 over -3 plus 1, which gives me 2. The horizontal asymptote occurs at y equals 1 because you'll see, you can look either here or here. the lead coefficients are 1 for the degree of the top and the degree of the bottom match. And the lead coefficients are 1 and 1. So y is equal to 1. And the x-intercept is x equals 1. The x-intercept comes from what makes the numerator 0. So if we plug 1 into the numerator for x, we'll get 0. And the y-intercept comes from plugging a 0 in for x. So the y-intercept occurs at -1. 0 for x leaves -1 over 1. Now when I go to graph this function, the first thing I did was draw that vertical asymptote, which is x equals -1, the horizontal asymptote, which is y equals 1. I have a y-intercept at -1, an x-intercept at +1, and just by the nature of these rational functions, I kind of have an idea the shape of this function. I forgot to mention that I also graphed here the whole. And the whole, if you'll remember, occurs when x is -3, right? 1, 2, 3, and y is 2. So I drew that whole too. Now I'm going to draw those C shapes on top of here. So it looks like this. So remember, these rational functions always have this same general shape. Sometimes there's something in the middle when we have two vertical asymptotes, but they're going to start to all look the same to you, or very similar. Not all the same, but similar. Okay, the last example is f of x is equal to 3x over x squared plus 5x plus 4. I can factor the denominator, so I'm going to do that. And there's no common factors that I can divide out. So what's the domain of this function? Well, it's everything except -4 and -1. And what's the vertical asymptote? There are two. There's a vertical asymptote at x equals -4 and a vertical asymptote at x equals -1. What's the horizontal asymptote? Well, the degree on the bottom is bigger. So since the degree on the bottom is bigger, the horizontal asymptote is y equals 0. The x-intercept comes from what makes the numerator 0. And that's when x is equal to 0. And the y-intercept comes from plugging a 0 in for x. So you get a y-intercept of 0. That means it's going through the origin. So I'm going to draw the horizontal asymptotes and the horizontal asymptote and the vertical asymptote. There's two of those, sorry. And I'm going to draw the x and the y-intercept, which is the origin. All right. Now, here's the vertical asymptotes. You can't really see the horizontal asymptote because it is the x-axis, remember? Because the horizontal asymptote is y equals 0. All right, I do crack myself up. And the origin is the x and the y-axis. That doesn't tell us a whole lot about the graph. Now you have those graphing calculators. By all means, graph it on your calculator to look. You could also plug in values to the left of this asymptote, between these two asymptotes, and to the right of this asymptote before the x-intercept and then after the x and the y-intercept. But you can also look at your calculator. And if you look at on your calculator, you'll see this general shape. I want you to notice that, the horizontal asymptote is the x-axis, but the graph actually does go through there. It still hugs the x-axis on the right-hand side of this graph, and it hugs it in the beginning. Okay, that's it. Good luck.